All right, CHEM 2212, we're doing our reduction of an unknown ketone or aldehyde using sodium borohydride. We're going to go through the preparation of our reaction vessel. First thing that we're going to do is weigh out 0.5 grams of our sodium borohydride, which is our reducing reagent. I've folded a piece of weigh paper so that we can more easily contain it on the scale. We'll go ahead and tare this. And we're ready to weigh it out. Okay, there we go. Now we're going to be putting all of this into a microwave vessel. That's how we're going to reflux. This is our Teflon reaction vessel. This is where we're going to start combining all of our reagents. I'm going to make a small funnel out of weigh paper so that I can pour in my sodium borohydride without having to worry about spilling it, or with minimal spillage. Be very careful here. Fold it along the center line and then down into the funnel. And we'll tap it out as best we can, get as much as we possibly can. I'll use my spatula to rake down any remaining. Okay. All set. Extra tap on the funnel here. And we're good to go. Now I didn't write down my data. I believe we were at 0.51. We'll go back and check that on the video to make absolutely sure. 0.51 grams. Whoops. That's for our aldehyde or ketone. Got ahead of myself here. So our initial weight of sodium borohydride, 0.51 grams. All right, next we're going to measure out 20 mils of our ethanol. So we've got our graduated cylinder, 100 milliliter. We've got our 95% ethanol here. And we'll use our pipette to get exactly 20 milliliters, and we'll pour that into the reaction vessel as well. Okay, close to 20, a little bit more. And there we go. All right, we've got our 20 mils of ethanol. We'll pour that into our reaction vessel. And now the last ingredient is going to be our unknown ketone or aldehyde. And we're using unknown 5A for this experiment. And we're going to be doing 2 mils of our unknown, so I'm going to be real delicate here. Okay, right at 2. Go ahead and add that to our vessel as well. We'll add in a stir bar. We'll cap it. Now this has got an open cap. This is our ATC vessel. So you can see here for room 121. Whoop. And what we're going to do with this vessel is, this is what we're going to use to monitor the temperature. This is a thermal well. This goes down inside the reaction mixture. And it has a small space inside of it. That's where we're going to put our temperature probe that's going to help us monitor the temperature of our reaction. Okay. We'll put that into our outer sleeve, and then we'll put it together when we get over to the microwave. Okay, so we're here at the microwave unit, our FlexiWave, and we're going to go ahead and set up our temperature probe. This is what's going to allow us to measure the temperature during the course of the reaction. I'm going to loop it through. There's a small holder at the top of the unit, and that's going to help it stay untangled from the rotor as it spins inside the main microwave unit. So that's going to dangle there for a second while we get our rotor set up, and that's over here. We've got our reaction vessel. We have all of our components here in the Teflon tube. We've got our ATC cap, which has got a pass-through hole straight through and through. We'll have to get our wafer. Where did our wafer go? Here's our wafer. Our wafer that goes into the top of the cap. That's going to set here, and that's going to allow the vessel to vent through the vent hole. I'll show you that. And the vent hole is right here. So as the pressure starts to build during the course of the reaction, it will vent gases into the unit, and that'll be whisked away into the hood to keep it safe. Okay. So what we're going to do is we're going to set our vessel in the 1 position, and I'm going to pick that up and take it over into the unit. Okay. I'll get my cap and my wafer. I'll set the wafer just inside like so. And I'm going to thread my probe through the top of the cap very gently. These are very expensive probes. And then I'm going to slip it down into the thermal well inside of our reaction vessel. And then I'll screw it closed, and then I'll set the probe in place once I've got everything screwed down tightly. Okay. I always have my vent pointed to the outside of the carousel. I'll set my probe in very firmly so it doesn't pull free, otherwise that will cause an error. Make sure that I'm attached appropriately. Now I've got to put the, I guess we'd say the guard on the top of the unit here so that our vessel does not tip over. Just sits down just like that, and we're all set. Normally we would have 12 in there. Today we're just doing 1. We'll go ahead and close it up. This is our control unit. We've already got our appropriate method selected, and all we have to do is hit go. Okay, our method is almost completely finished. We wanted to give you a look at the control panel for the microwave. That's one of our hot plates beeping behind us. So what we have here is the temperature curve. You can see at the top part of the curve, that is where our heating cycle was, where our actual reflux is. And then this tailing off curve here shows us as the vessel is cooling down in the system. When it gets to 60 degrees, which it has, it's at 57 right now. I'll go ahead and tap that and you can see we're at 57 degrees. The machine actually just shut off and unlocked. I don't know if you could hear that on the video. That's when it's safe to take out, and then we'll open the vessel in the hood just to make sure no pressure has built up. I was going to show you the rotation inside the vessel, but of course now that it's stopped, it's not rotating anymore, but you could see these numbers cycling through, showing you how it was moving within. We got a glare probably. Try it. Inside the vessel, and then you can also see there's a camera that shows you the shot inside. So here's our ATC vessel right here. That's our reaction vessel. And we'll go ahead and take it out and get it extracted. Alright, so we got our vessel out of the microwave and we're ready to start the extraction process. We're going to go ahead and open this up. Always face the vent away from you. But this has been cooling for quite a while, so we shouldn't have too many problems here with pressure buildup. So we'll go ahead and take the Teflon vessel out, and we'll place the outer covering aside, along with our Teflon wafer. I'm going to take the thermal well out as well. Lay that right next to it. And then we're ready to pour our solution into the sep funnel. Always make sure that your sep funnel is closed before you pour anything into it. We'll go ahead and add in our reaction mixture. I'm going to pour my spin vane into the funnel as well. We'll rinse it. We've got a little bit of solid, I don't know if you can see that, a little bit of solid that we may have to remove before we go through, but let's see if the water will rinse that through. We've got our deionized water. We're going to do 60 mils. And there we go. A little bit above 60. We'll make a note of that in our data sheet in just a minute. We'll pour our 60 mils into our solution, or into our sep funnel. And that solid is causing a little bit of a problem, a little bit of backup, so I'm going to get a spatula. See if I can't chop it up just a little bit. There we go. And we keep pouring the rest of our water. Tip out this spin vane real quick to get that out of our way. Can you see the two layers there? I don't know if that's showing up. Is that showing up right now?
Yeah, it is.
All right. So our next step, so we've done our 60 mils of water. We're going to extract our product from our aqueous layer with two 25 ml portions of methylene chloride. So we've got our methylene chloride here. Of course, I'm doing this under our snorkel, just to make sure that we're being extra careful. Okay, we're right at 25. Go ahead and pour that in as well. And we'll start our extraction. We'll go ahead and close up our methylene chloride. And we'll set aside our funnel. Put my cap on top. I'm going to take it out of the ring clamp. Should be able to see our two layers. And we'll give it a good shake. I'm venting this away from the camera and away from the cameraman and myself. We'll vent it up into the snorkel. Give it another shake. Up into the snorkel. And then a third shake, and then we're going to be good to go. We're going to let that separate for a minute, and then we'll drain the layers. Okay, so we've let our layers separate. As you you can see we've got a fairly nice boundary here between the two. Our bottom layer is our methylene chloride. That's where our product is going to be located. So we're going to go ahead and drain that bottom layer into our catch beaker. I'll do it a little bit quicker at first, and I'll slow down as we get closer to the boundary and the separation of the two layers. So we've got a little bit of our methylene chloride that's still in there, but that's okay. We're going to be extracting with another 25 ml portion of methylene chloride. So I'll go ahead and put my funnel back in, pour in my next portion of methylene chloride, and we'll go through our extraction process one more time. Quite a pressure build up that time. As you can see, I actually got some onto my gloves here, so I'm not going to shake quite as vigorously last time. In fact, I'm going to go ahead and change my gloves right now, and then we'll come back to it. Okay. Now we have our first extract already in the beaker below. I'm going to turn this around. We're going to let this separate out just for a second, and then we'll drain our second portion into the same beaker. This does take a little bit of time to separate, not too much. Just got to get some of those bubbles at the interface. All right, let's start draining it down. And we're going to try and keep as much of that water layer out as we possibly can. And I'm going to agitate it just a little bit. Just if there's any methylene chloride left, we see a little bit down in the bottom. Drain that down, and I think that's about as close as we're going to get it. There may still be a little bit of methylene chloride that we missed, but that will be negligible. Okay? But also a possible source of experimental error or loss of product, right? So something that we need to note in our lab report. So we have our two portions of methylene chloride. I'll set those to the side. I'm now going to drain out, but not with the top on. I'm now going to drain out our remaining aqueous layer. We're going to hold on to this until the very end. We don't want to throw anything away until we have obtained our product at the end. We're going to put our methylene chloride layer back in, and then we're going to wash it with 4 60 ml fractions of deionized water. We're going to measure those out beforehand, so you don't have to watch us measure them. And then we'll come back. Okay, we've measured out our 4 60 ml portions, and we're going to go through. We're going to pour our methylene chloride back into our funnel here, and then we're going to wash it. Now, the difference between extracting and washing: extraction is where we're taking a substance into another layer, like our methylene chloride layer. We're extracting our product. We're taking it out of the aqueous layer and putting it into our organic layer. Washing is removing impurities while our product remains in place. So our product is going to stay in the organic layer. The impurities are going to go out with our aqueous. So we're going to go ahead and pour this back in. So there's our methylene chloride layer. We'll put in our first of 4 DI water layers. and we'll extract again, or we'll wash. We will shake our vessel and wash our product layer. Okay, I'm going to get another beaker real quick. Well, actually, we'll just use this beaker and we'll just pour it back in. We'll use this is our waste beaker here. So this is where our original aqueous layer is. So that's where we'll drain off our additional water layers. So you can see our separation once again. Let's give that another good swirl. You can see the droplets down throughout the bottom layer. We want to try and get those to move if we can. Get them to incorporate into the upper aqueous layer, but they're pretty stubborn and they're not moving at all. So we'll go ahead and drain them in. We're going to dry this layer, this product layer, in just a little bit anyway. Take a little bit of the aqueous layer just to make sure that we've got it all. So this is our organic layer. We're going to set that aside. Here's our waste beaker. This is our upper aqueous layer that we're going to drain into our waste beaker. Probably to make this a little bit more efficient, rather than draining it out the bottom, we'll just pour it out the top. Okay, waste beaker will go back into the background. We now have to pour our organic layer back into the step funnel. And then we add the next portion of the eye water. We're going to let this separate just like we did before. We'll drain off the bottom layer, rinse and repeat. Okay, so we've finished our fourth and final washing. As you can see, we've got our aqueous layer on top, our methylene chloride layer on the bottom. So we're going to go ahead and drain out our methylene chloride layer, that's the layer with our product, into our beaker here. And then we'll discard the upper aqueous layer. There we go. I'm going to swirl it just a little bit to see if there's any remaining methylene chloride in there. Doesn't look like it. We got it out pretty good. So we'll take this. This is our product layer. Go ahead and drain this aqueous layer out of the SEP funnel. We're going to go ahead and discard this. We'll discard it after we get our product out of our bottom layer here, just making sure that we haven't accidentally mixed up the layers. Don't think that we have, and the main reason for that is because if we had mixed them up, we would see two layers forming in our catch beaker here. So we feel pretty good about what we've done so far. Now we've got to take our product and we're going to dry it with magnesium sulfate. This is our drying agent. That's going to take any of the aqueous component that came down into our organic layer through the sub funnel, and it's going to dry it up for us. We're not weighing out a specific amount. We're just going to add in some of this powder and give it a swirl. And essentially what we're looking for, if you can see, I don't know how easy it is to see that, some of that powder has stuck to the sides of the beaker, down to the bottom edge here. And then the majority of the powder, however, as I swirl it around, is still free in the beaker. So as long as we have free powder, that tells us that our solution is dry. Where we're sticking to the beaker, that's where our magnesium sulfate aggregated with water. Is it better if I tilt it like that? No. Okay. So we've got a fine powder layer on the bottom of the beaker, and that shows us that we've aggregated all the water out of our solution. So now we're ready to filter this into our round bottom flask so that we can go obtain our product. Okay, before we filter our solution, removing our drying agent, we need to go ahead and weigh our round bottom flask so that we can determine our final product weight. The way we're going to do that is we're going to take a 400 ml beaker, set that on our scale. We're going to hit tare. Hopefully it will zero out for us. There it goes. And then we're going to gently set our beaker. Whoop. We've got to give it a second to calm down. We're going to gently set our beaker. That's interesting. Inside of it. And get our weight. So our weight is 73.26. 73.26. Good. So we got 73.26 is our 100 ml round bottom flask. Now we'll go ahead and filter our solution. Okay, so we've got our drying reagent in, so we've dried up all of our extra water in the solution. Now we've got to filter it into our round bottom so we can go rotovap it. So we're going to have to use some fluted filter paper, and one of the easiest ways to get this to fit into this funnel is to fold it in half a second time, and then take one of our folds and pop it open like so, and you can see that it makes a nice even funnel shape. We'll put that into our funnel here, and I'm going to hold it on one side until we start pouring so it doesn't pop out, and we're going to gravity filter our solution here with our solid drying reagent. We'll do this slowly so it doesn't overflow. After the liquid has absorbed into the filter paper, it sits in the cone very nicely. You don't have to hold it. And we'll just let it drain through slowly but surely. Bring my funnel down to make absolutely sure we're not breathing in any fumes. Got to be safe. does take a little while, but it's extremely important. We don't want our product to get caught up in our drying agent. Once this finishes filtering, we'll take it over to the rotovap and we'll take off the methylene chloride. Okay, so we've finished our filtration. We've got our liquid. This is our methylene chloride with our product. We're going to put it onto our rotary evaporator and drive off the methylene chloride, so we'll be left with our product. So the way that we do this is we'll set it up on the end of this trap very carefully. Put our cat clip on. That's going to hold it in place. This is our water bath. We're going to heat this up just a little bit, not much. Methylene chloride is pretty volatile, and especially when we're under vacuum the way that we're going to be, this will drive off the methylene chloride pretty quickly. So this is our heated bath. We're going to be spinning as we do this. See if you can make that out. So we're going to be spinning slowly, which is also going to help with the evaporation. You can see, if we look in the coils here, this is our condenser unit. So our vapor is going to go up the barrel of our trap into the condenser. It's going to hit these coils, and they're filled with, as you can tell by the condensation that you see right here, very cold liquid. It's a mixture of ethylene glycol and water. So it's at -5 degrees. We turn the pump off so that you can hear us speak. When we get ready to start this evaporation, we'll have to turn it back on. But we've got very cold liquid flowing through these coils, so that when the vapor hits it, it'll immediately condense and we'll catch it in the bulb here. So we'll separate out the methylene chloride to here. Our product will be in our 100 ml round bottom flask, and we'll go weigh it at the end to determine our final product weight. Now it's time to turn everything on. We are going to turn on our vacuum back here. And you'll hear that hissing sound. That means that our vacuum at the top, our inlet, is open, so we're going to close that so we can maintain our vacuum. That's going to pull the vapor up into the barrel. We're going to lower our flask into our warm water bath so that it comes in contact with the water. We've got our vacuum going, and we're all set. We'll pick back up once we've gotten everything removed. Okay, so we've removed all of our methylene chloride. If you look in the bell here, you can see that it's not full, but that's basically the volume that we had in our round bottom in the beginning. I'll slow this spin here. And we've reduced our volume down significantly. So that is our product, our liquid product, that we're going to then take into the next room and inject into the pico spin to get a spectrum. Okay, so we've taken our flask off the rotovap. We've now got pure product. No more methylene chloride. So we're going to go ahead and weigh this flask again, just like we did before. We'll subtract out the weight of the flask, and that'll give us our total product weight. Okay, and our value is 74.73. 74.73. So we'll go ahead and do our simple math here. That gives us 1.47 grams of our final product. And that's our total weight of our product. Okay, so now that we've got all of our numbers, we've got all of our data here, remember you're going to have to take your unknown. Our code in this case was 5A, so you're going to use the appropriate NMR to determine the identity of 5A. Once you know the identity of that compound, you're going to be able to find out its density. You're going to come back and apply that density to your 2 mils of starting material. That's going to tell you how many grams of starting material that you had. You'll then convert that into moles. This is a 1-to-1 conversion between our carbonyl and our alcohol. So you'll take your 1.47 grams of your alcohol product as a result of the reaction, convert that to moles, and do your comparisons for your overall percent yield. Okay. Now we're going to head over to the pico spin, We're not going to go through an entire injection process. I just wanted to show you the instrument one more time. We've got the PicoSpin desktop NMR unit. This is an 85 megahertz machine. We've got an inlet and an outlet. This is a capillary, this is a loop that goes through the center of our electromagnet. So what we'll do is we'll take a little bit of our final product, put in some TMS, inject it into the loop, and we'll get a proton spectra with which you can characterize your unknown. Good luck.